Myself, Dr. Vinod. I am working as Associate Professor in Marri Laxman Reddy Institute of Technology and Management in the stream of Electrical and Electronics Engineering. I am here to teach the principles of Electrical and Electronics Engineering. In this context, I am going for the Unit 1, that is DC circuits. So, here it is, the DC circuits on the screen. So, the DC circuits, first of all, what is DC circuit? DC circuit is nothing but it is a closed path where the current flows only in one direction. Once again, I am repeating, the DC circuit is nothing but it is a closed path where the current flows only in one direction. The DC is it's a constant electrical charge that flows from higher potential to lower potential. Moreover, the DC circuits are just like the low voltage applications. So generally, if you see the battery, those kind of power rated are low voltage applications. So the DC circuits are put in that domain. Next. So in the DC circuits, first we are going to see the topics. The subtopics are electrical circuit elements. The electrical circuit elements are resistance, inductance and capacitance. The elements are resistance, inductance and capacitance. After that, we are going to see the Ohm's law and its limitations. And after that, the basic definitions of electrical work, power and energy sources. So today we are going to cover all these topics. So in this context, first we are going for the resistance. So first of all, the word resistance. What is resistance? So if someone is talking about the resistance, means it is stopping something. So in electrical engineering also, we see those kind of things that we call it as electrical resistance. So electrical resistance is nothing but it is the resistance that opposes the flow of current. The moment I'm talking about resistance means it's stopping, right? So electrical resistance means that is opposing the flow of current. Which opposes the flow of current, that we call it as a resistance, and it is denoted with respect to symbol that is R. And we can see here the diagram that resistance is represented by like this. This is the one. And here you can see the two sources like voltage source and current source. Throughout the electrical engineering, whenever I talk about the elements, I definitely, and it has to be uttered like the current passes through the parameter and the voltage across the parameter. This type of funda we need to deliver, because whenever I'm talking about current, I cannot say that the current across the parameter, voltage through the parameter. You have to utter the word like the current passes through the parameter, voltage across the parameter. So here, after that, we have the formulae like resistance. Here, what is that? R. R equal to rho L by A. So the formula is R equal to rho L by A, where we see that this rho is nothing but what? Resistivity of the material, and A is area of the cross section and L is length. So whenever I am talking about the resistance formulae, definitely I have to talk all these three, that is resistivity, length and area, and that is indicated with a unit ohm. So during the competitive exams, you may find the finding of resistance. So whenever they ask us to find out the resistance, this is a formula we need to apply. R equal to rho L by A, and the source is taken from technical publications UA Bakshi. So next, after that, we are going to see the voltage and current relations of a resistance. So I of t is equal to V of t by R. Here I can say like I is related with V with respect to R. After that, the V is related with I with respect to R. So, the moment I am talking about I of t, I of t is nothing but current. The current that changes with respect to time is equal to voltage that changes with respect to time divided by R. So, and the voltage is given from here, from this formula, like the R is moving towards the left hand side crossover, I can write V of t is equal to I of t into R. So, here V of t means what? Voltage that changes with respect to time. Again I of t that changes with respect to time. So, till now we have seen the basic definition of a resistance and the formula of a resistance. After that we have seen the voltage and current relations of a resistance. So, next we are moving for the next electrical circuit parameter, that is inductance. Okay, inductance, it is denoted by L, whereas the resistance is denoted by R. Similarly, inductance is denoted by L. So, next let us go with the inductance. So, inductance has a property, and it has the property like which opposes the sudden change in the current passing through it. That we call it as a inductance. Inductance means what? It opposes the sudden change in the current. That is called inductance. As we told already, it is denoted by L. As we can see in this diagram, Q 1.2, that is Q 1.2, here it is. So, where the inductor is represented by a coil, and already I told, right, a current passes through this parameter, voltage is across this inductor. So, here we can see the flux is developed here, and I can show the equation for that one also in the coming slide. So, let us see that equation. So, next point is what? It stores the energy in the form of electromagnetic field. After that, it is measured in Henry's units, and already I told, right, there is something called this flux. How it is? See, the L is defined as with respect to flux linkage as L equal to N into phi by I. So, here it is given the one more definition for that. What is that? The total flux that is linking with the coil divided by the current producing the flux. L equal to N phi by I. L equal to N phi by I. So, after that let us see the current and voltage relations of this L. So, let us see. So, what is that? Obviously, when you talk about the current relation means obviously the left hand side you are going to get I. That is IL means inductive current with respect to time, that is given by 1 by L 0 to t integral V of t dt plus IL of 0, where IL of 0 is nothing but what? It is the initial current through L, From this equation, if at all I am applying the derivative on both sides, I am going to get the equation for voltage. So, this is a basic relation between the voltage and current with respect to inductor. So, already we have discussed IL of 0 is nothing but it is a initial current through L. Next we are going for capacitance. So, there you are, capacitance. The property of a capacitor is what? It stores the electrical energy in the form of electrostatic field. When a potential difference is applied across it, the capacitor stores the electrical energy in the form of electrostatic field. This is called capacitance. So, as we know that resistance is denoted by R, inductor is denoted by L, and capacitor or capacitance is denoted by C. So, here I can say like the current passes through this capacitor, voltage is across this capacitor. So, next This capacitance is measured in units like units. What are those? In resistance, we say ohms. Inductor, we say Henry. Here, we say the capacitance is measured in farads. So, next, C is given by C equal to Q by V. Next, we see the voltage and current relations. So, already we have seen the current and voltage relation resistance. Similarly, in inductance, next we are going for capacitance. So, this is the current relation with respect to voltage. Obviously, left hand side we see the current IC of t is equal to C into dVc of t by dt. Suppose if at all, if I apply integral on both sides, I am going to get voltage and current relation of a capacitance. That is Vc of t is equal to 1 by C integral Ic of t dt plus Vc of 0. So, here Vc of 0 is nothing but it is the initial voltage on capacitor. So, till now we have seen the three parameters like resistance, inductance and capacitance, definitions, formulas, voltage and current relations. So, after that, the factors that are affecting the resistance of a material. So, we have seen the formula, that is R equal to rho L by A. So, there you have various parameters that are affecting the resistance. So, if this question may be for 2 marks in the exam, like what are the factors that are affecting for the resistance of a material. So, the various factors that are affecting for resistance of a material are, first one is what? Directly proportional to length of material. Already we have seen rho L by A, R equal to rho L by A. What is that? Directly proportional to length of the material. Next, it is inversely proportional to the cross-sectional area of the material. That is A. And next, the type and nature of the material. This is rho. And it is dependent on temperature also. So, the 4 factors, right? Directly proportional to length of material, inversely proportional to cross-sectional area of the material, types and nature of the material and its temperature. So, after this, what are the important points that need to be remembered in DC circuits? The point number 1, that is electrical network. First of all, what is electrical network? Before that, what is network? Network is nothing but it is a combination, right? When you say that network, there is something common called combination, right? So, here we see the electrical network. Electrical network is also again the combination. So, the combination is like parameters and the sources. Here we have parameters like resistance, inductance and capacitance. They are the 3 parameters. Where you have again sources like current source and voltage source. Whenever I am talking about the electrical network, so these 2 will be added. What are those? The sources as well as the parameters. So, electrical network is defined like the combination of network elements and sources that combine together called as electrical network. And next, we are going for branch. So, after the definition of the electrical network, next we are going for branch. Next, what is branch? Branch is nothing but which connects a network, a part of the network which connects with various parts of the other network. That is called as branch. Means network connection with other network. That we call it as a branch. Next we are going for junction point. A junction point is nothing but where 3 or more branches are meeting, that we call it as a junction point. Next, we are going for node. What is node? Node is nothing but where 2 or more branches meet, that we call it as a node. So, next, in this line we are going for mesh or loop. So, this is a most important point. Like while solving the problems, the mesh or loop analysis. So mesh or loop analysis is nothing but it is a set of branches forming a closed path in a network in a such a way that one branch is removed, then the remaining branches do not form a closed path. So it is like a mesh or loop is like a closed path. If at all suppose I am removing one branch, it cannot form a closed path with the remaining branches. So once again repeating, the important points need to be remembered here are electrical network, branch, junction point, node, mesh or loop. So these basic definitions are very much important for 1 or 2 marks that can be given in the examination. So next we are going for the Ohm's law. This is our next in the topic, Ohm's law and its limitations, right? So Ohm's law. So I hope from your physics you people are listening. This Ohm's law from +1, +2, but again it's like few people are unaware of that with few conditions. So let us see exactly what is Ohm's law. Ohm's law that gives the relation between the potential difference V, current I and resistance R of a DC circuit. So it gives a relation between V, that is voltage, current I and resistance of a DC circuit. This is the most important point. It is of a DC circuit. DC circuit relation for voltage, current and resistance. So mathematically I can say like I proportional to V by R. What is I here? I is current, V is voltage, R is resistance. So let us see the statement. It states that the current flowing through the electric circuit that is directly proportional to the potential difference across the circuit and that is inversely proportional to the resistance of the circuit. The point it is trying to say that current is directly proportional and indirectly proportional. That current is directly proportional to voltage and indirectly proportional to the resistance. That's why it is mathematically given as I proportional to V by R. Here where I is what? Current flowing in amps, as we know that current units are amps, where V is nothing but voltage applied, R is resistance of the conductor. So if I remove the proportional constant, then I can write I equal to V by R. One thing need to be remembered is I is directly proportional to voltage applied and I is inversely proportional to that is resistance. So this is for of DC circuit. So next, so if you see here the Ohm's law, the current passes through resistance and voltage across the resistance. So here Ohm's law is I equal to V by R in amps, or I can write V equal to IR in volts, or V by I equal to constant that is equal to R ohms. So here the point to be noted, the unit of potential difference is defined such a way that the constant of proportionality is unity. Constant of proportionality is unity. Ohm's law is defined as what? I can write from here, I can say that it is a ratio, right? The ratio of potential difference between 2 points of a conductor I flowing through between them is constant, and provided the temperature of the conductor remains constant. Initially I told, right, something are unwritten, something are unlistened, like yes, the point to be noted is what? That is provided at a temperature, provided the temperature of the conductor remains constant. I am saying that, or the context of whatever this Ohm's law says us that it is to be operated at a constant temperature. If at all we are not uttering a word, the constant temperature, then the complete definition is going to be useless. Next, the limitations of the Ohm's law. The limitations of the Ohm's law are that is not applicable to non-linear devices such as diodes, Zener diodes, and etc. So, because here you have to observe one thing, sir, why people may ask, sir, why this Ohm's law is not applicable for this? Because those doesn't have the linear character. Like if suppose if at all if I take I and V character, it is not linear in nature. That's why they doesn't suit with Ohm's law doesn't suit with Zener diode and diode. Try to understand that. Okay, next. It is not applicable to electrolyte. It is same again. The IV characters are not in linear in nature. Similarly, it is not applicable to discharge lamps and vacuum tubes. And the point to be noted again here, repeated, but still it is important, right? It is valid only at a constant temperatures. Constant temperatures. Okay, right? Next. Next, we are going for the basic definitions of electrical work, comma, power, and energy. So, in this context, first let us go with the electrical work. First of all, what is work? So, in basic physics, when you see the work is nothing but the force is applied on object such that it moves certain distance, like force into displacement. So we say that is work, right? That is work. But what about the electrical work? Electrical work, similarly, this is also one type of a work. Something need to be moved to one point to other, right? So there you are. So in this electrical circuit or in this electrical engineering, the electrical work is defined like this. What is that? The movement of electrons, that is the transfer of the charge takes place. The transfer of the charge takes place. Like the electrical work done is uttered like there is a transfer of charge. There is a transfer of charge. The unit of such work is joule. The unit of such work is what? Joule. So next, the point to be noted is if 1 joule of electrical work is done, then what is happening? The charge of 1 coulomb and 1 potential difference of 1 volt. Try to understand. This is most important point, right? 1 joule electrical work is done to be a moving of 1 charge through a potential difference of 1 volt. 1 joule moving of 1 charge and through a potential difference of 1 volt. Okay, so if V is the potential difference in volts, then Q is a charge. Then I can write like electrical work W equal to V into Q, that is measured in joules. As we know that I equal to Q by T. So substitute that value here. Q equal to IT. Q equal to IT. So I can write W equal to V into I into T, that is measured in joules, where T is nothing but T is time in seconds. So this is all about the electrical work. So next let us come to power, that is electrical power. So we have seen the basic work and we have seen the electrical work, and after that power and electrical power. Let us see what is power. Power means what? I have power means what? I can able to make that work to be done. That is called power, right? Similarly, if I attach that electrical word to this power, then I am going to get the electrical power. The same fundamental that is happening in electrical engineering with other parameters. That's why we call it as the electrical power. Here it is. The rate at which the electrical work is done in electric circuit is called electrical power. So simple, right? So the rate at which the electrical work is done in electric circuit, the electrical work is done in a electrical circuit, that we call it as a electrical power. So next, the electrical power P. P is denoted by what? Electrical power P is denoted by electrical work with respect to time. Electrical work with respect to time. Next, that is given by electrical work given by W, time is T. So here already we have received W equal to VI T over there in the previous. So I am substituting VI I into T by T. So finally I can write V equal to P equal to V into I. P equal to V into I, that is joule per second. Joule per second. Next, point to be noted here. Thus, the power consumed in electric circuit is what? 1 volt. If the potential difference of 1 volt applied across the circuit, 1 ampere current flows through it. Right. The point is what? Power consumed is 1 watt. For suppose I am saying that power consumed is 1 watt. Then what is happening? The potential difference applied is 1 volt and the current is 1 volt. So such a way that P equal to V into I. I am saying that V is 1 and I is 1. Obviously I am going to get 1 W. 1 watt is equal to 1 V into 1 ampere. So this is all about the electrical power. So 1 watt is equal to 1 joule per second. Next, as you know that the power watt is small, many a times power is expressed like kilowatt and megawatt. Kilowatt means what? It is a 10 to the power of 3. Megawatt means what? It is 10 to the power of 6. The moment I say megawatt, that is 10 to the power of 6 m. K means 10 to the power of 3. So according to the Ohm's law, we know that V equal to IR, I equal to V by R. So power can be expressed in many types like P equal to V into I. So here I can write V equal to IR. IR here means, so what is that? So V equal to IR means here I can write I R into I. So I am going to get I square R. This is I square R. So next, again we have I equal to V by R. If I apply I equal to V by R here, what is happening? So V into here I equal to V by R. So I am going to get V square by, so it's this is equal to V square by R. So this is V square by R. Here what is R? R is resistance in ohms. Next, electrical energy. Let us see the next, electrical energy. Electrical energy. And electrical energy is nothing but what? It is a total, again, energy, electrical energy. Okay. So electrical energy is nothing but what? Total amount of electrical work done in a electric circuit. Total amount of electric work done in a electric circuit. The electrical energy is given by what? It is multiplying factors of power and time. That is V of I into T. That is given as in joules. That is given as in joules. The unit of energy is joules, or I can write it as watt or second. So next, the energy consumed by electric circuit is said to be 1 joule or 1 watt. It utilizes the 1 watt or 1 second. Same, the one proportion, the unity proportion we are bringing on from work, power and the energy. So as watt second unit is very small, the electrical energy is measured in bigger units, and that is like WH and kWh, that is kilowatt hour. So I can write like 1 watt hour is equal to 1 watt into 1 hour. 1 watt, that is again hour turned into seconds here, that is equal to 3600 watt second. Again 1 kilowatt is equal to 1000 watt. So I can write it as 10 power 3 here. So 3600 joules. So 3.6 into 10 to the power of 6 joules. So note, when a power of 1 kilo ohm is utilized, what is happening here? If you turn this picture, if you turn this formula picturization, so when a power of 1 kilowatt is utilized for 1 hour of energy consumed is said to be what? 1 kilowatt hour. 1 kilowatt hour. Once I am repeating here, what is happening? Power of 1 kilowatt is utilized for how much? 1 hour of energy is consumed is said to be 1 kWh. The unit is called Board of Trade unit.